in section 4, we are going to talk about exponential and logarithmic form. So in section 3, we talked about how to solve an exponential equation where you could rewrite so that both sides were in the same base. But that's not always going to be the case. Sometimes we're going to need to express our exponent or our variable in terms of its base and y. In order to do this is we use a logarithm, which is the inverse of an exponential. So all the properties of an inverse apply to it as well. So if we have y equals b to the x, which is our exponential form, to convert it to logarithmic form, we do x equals log base b of y. So a logarithm solves for an exponent. So before we get into actually solving, let's just go ahead and practice going between the two forms. So I have equations in exponential form and I want to convert them to logarithmic form. So I have 2 squared equals 4. So when I convert it to a logarithm, you're going to have log. The base of your exponential equation becomes the base of your logarithm, which in this case is 2. Then inside your parentheses is what you're equal to, which in this case is 4. And then you set it equal to your exponent, which in this case is 2. Our second example, 3 to the negative 4th equals 1 over 81. So it becomes log base 3 of 1 over 81 equals negative 4. Our third example, we have 4 to the x equals 16. So we'll have log base 4 of 16 equals x. And our last example, 2 to the x equals 7. Log base 2 of 7 equals x. Next, we're going to talk about how to go from logarithmic form to exponential form. So we're not only going to use logarithms to solve exponential equations, but we can use exponentials to solve logarithmic equations. So I have log base 7 of 343 equals 3. So the base of the logarithm becomes the base of your exponential equation, 7. What you're equal to becomes your exponent, 3, and then equals what's inside, 343. The nice thing about this is you can always double check that you've converted from logarithmic to exponential form correctly because you end up with a true statement. So if I were to do 7 cubed in my calculator, I should end up with 343, which we do. Our second example, log base 5 of 1 over 625 equals negative 4. So my base is 5, my exponent is negative 4, and then it equals 1 over 625. Then for our last example, log base 4 of y equals 7. It becomes 4 to the 7th equals 1. So now that we've talked about how to convert from exponential to logarithmic form, we now want to talk about how do I now evaluate that logarithm that is in that has that base. So in general, logarithms are actually base 10. So if you just see log of y equals x, if you don't write that base number is 10. And in your calculator, the log button is in base 10. So it doesn't evaluate a logarithm that isn't base 10. So we have to know, well, how can I then evaluate a logarithm with a base other than 10? And that's what our change of base formula is. It says if you have a log with some base b that is not 10, so here the base is not 10, and you're evaluating it with some number a, that's the same thing as doing log a over log b. So you convert it to a division problem with a logarithm with base 10. So we're going to go ahead and use that to evaluate some logarithms. So we have log base 2 of 8, which once I convert becomes log 8 over log 2. And if you use that button in your calculator, you're going to end up with 3. Our second example, log base 7 of 24. We're going to have log 24 over log 7, which if you use your calculator, it is important that whenever you're evaluating a log in your calculator, you do close the parentheses after you type in your numerator. And it's going to be 1.63. So it's not going to be a nice number, it is going to be a decimal. And then our third example, log base 3 of the square root of 18. We have log square root 18 over log 3. Which is 1.32. Now, unless I tell you otherwise, anytime you have to round when evaluate a logarithm, go ahead and round it to 2 decimal places. So let's go ahead and solve some exponential and logarithmic equations by switching between the two forms. So for our first example, we have 16 to the x equals 64. So I could technically solve this by rewriting them with the same base because 16 and 64 can both be rewritten as powers of 2. But we're going to go ahead and use logarithmic form so you can see how to get the answer. So when I convert it to logarithmic form, I get log base 16 of 64 equals x. Now I just have to evaluate log base 16 of 64 using my change of base formula, which is log 64 divided by log 16. So we're going to get that x equals 1.5. When it comes to showing work on a quiz for something like this, I do need to see the conversion from exponential to logarithmic form, but you're not required to show me the work for the change of base formula. You can leave it, you can skip that part, but you have to show me how you converted it from exponential to logarithmic form. Our second example, 3 to the x equals 8. Now I cannot solve this equation by rewriting both of them as the same base. So my only option here is to use logarithmic form. So it becomes log base 3 of 8 equals x. So my calculator, we're going to do log 8 divided by log 3. And we're going to get x equals 1.89. Our next example, 8 to the x plus 1 equals 9. So when I convert to a logarithm, it's log base 8 of 9 equals x plus 1. So in my calculator, we're going to do log 9 divided by log 8. And we're going to end up with x plus 1 equals 1.06. Now I'm not done. My previous examples, my exponent was just x, but that's not always going to be the case. So in order to solve for x here, we're going to subtract 1 from both sides, and we're going to get that x equals 0.06. In our third example, we have 3 times 2 to the x minus 2 equals 8. Now before I can convert to logarithmic form, the only thing that I can have on that left side or wherever my exponent is the base number with that exponent. So I have to get rid of that 3 that's in front by dividing both sides by 3 first. So we get 2 to the x minus 2 equals 8 over 3. And we are not going to put a decimal here because 8 divided by 3 is not a nice decimal. It is a non-terminating decimal. It is 2.6 repeating, and I don't want to round until the very end. So when I convert it to logarithmic form, my base is going to be 2 of the 8/3 equals x minus 2. In our calculator, we're going to do log of 8/3 divided by log 2, and we end up with x minus 2 equals 1.42. So to solve for x, we'll add 2 to both sides, and we get that x is 3.42. Our last two examples, we are going to solve the logarithmic equations. Now, we will talk more about how to solve logarithmic equations in section 5, but this is going to be just a very basic solving a logarithmic form. So we're going to start with converting to exponential. So my base of my exponential equation is 8. My exponent becomes 3 equals n plus 1. We're now going to evaluate 8 cubed, which is 512, equals n plus 1. Then we're going to subtract 1, and we get that n equals 511. So remember, 8 cubed is 8 times 8 times 8. It is not 8 times 3. And for our last example, we have log base 2 of x equals 7. So converting to exponential form, my base is 2, my exponent is 7, equals x. And now I just have to do 2 to the 7th in my calculator. So I get x is 128. Let me know if you have any questions about converting between exponential logarithmic form, evaluating a logarithm using change of base, or solving an exponential or logarithmic equation.